Hey guys, welcome back to another JavaScript programming tutorial, and in this tutorial I'm going to be showing you guys how we can use recursion and what recursion is. So recursion is basically just when you call a function from within itself. So the function is recursing back onto itself. And a simple example of this is just going to be the Fibonacci numbers. So if we want to get the Fibonacci number, well, we know the Fibonacci of n is just going to be the Fibonacci of n minus 1 plus the Fibonacci of n minus 2, right? And we have to define what Fibonacci of 0 and Fibonacci of 1 is. So if we given these initial conditions, then we can calculate what Fibonacci of 2 is, because it's just going to be Fibonacci of 1 plus Fibonacci of 0, which is just going to be 1 plus 0, which is equal to 1, and then this process just continues on forever. And this is a classic recursive demo. I'll show you guys how to implement it, and yeah, Fibonacci is just going to be, well, we take in the number we want, or just like that. And the thing you need to understand with recursive function is that there's going to be certain base cases where we don't want to return a self call to the function, but rather we just want to return an absolute value. And we need base cases because otherwise our function will just go on forever and we'd reach the maximum recursion depth. So the base cases for our Fibonacci number are just going to be if num is equal to 0, we return 0, and else, or if num is equal to 1, we return 1. So see here, we're just implementing these two base cases conditions here. And then there's always a recursive case if it's a recursive function. And in our case, it's just going to be, we return the Fibonacci of num minus 1 plus the Fibonacci of num minus 2, like this. And we are just going to return a number. So yeah, here's a simple demo of the Fibonacci. You can see I've implemented the base case and a recursive case, and this works pretty well. So now we can actually work out what Fibonacci of 3 is going to be. Let's write it out ourselves so we know it goes 0, 1, and then 1, 2, 3, 5. And 3 is going to give us the index at 3, so 0, 1, 2, 3. It should give us 2. Let's see what this gives us. So and yeah, there we go, we get 2. We'll see if we take the 5th Fibonacci number, we should get a 5. And you can see if we go to Fibonacci of 10, we get a 55. Now one thing about this recursive algorithm is that for each call, we're actually going to call the Fibonacci number twice. So this is going to have a time complexity of O of 2 to the n, because we're making 2 calls for every call we make. And if you imagine this as a tree, it's going to start here and then keep going recursively down, making 2 each time. So this is highly inefficient because we're making duplicate calls. We're also going to be making a lot of duplicate calls because calling this is going to just invoke the same thing as calling this on the next iteration. And we can fix that using techniques such as memorization, but generally recursion is slightly less performant than just iteration, but it makes up for it in its simplicity. So let's think of just another simple example. Let's just say count to, and we'll say we have the current num, which is just going to be a number, and we want the maximum, which is just going to be another number. So this time we're not really returning anything, but we do just have base cases. So what I want this count to function to do is, I'm just going to write over here, count to 3, I want it to output 1, 2, 3, like so. So what I can do is num, this is going to supply the current number we're on, and if our base case is actually going to be at the end, so if num is equal to, or we can say if num is greater than max, so if our current num is greater than the max, then we just want to return and break out of this sequence. So we've stopped this, otherwise we just have the recursive case. So we deal with the current num. Let's just console.log it, and then we recall this function for num plus 1, keeping max the same. And you can see what this will do. So if we had 3, well, first thing we'd actually have to count 2, supply the initial number as 0, and then count to 3. This is just going to say print 0, add 1, print 1, add 1, print 2, add 1, print 3. Then it's going to add 1, get to 4, so num is 4, but now num is greater than max, so it just returns out of there, like that. And let's see this function in action. So again, we don't actually have to console.log it since it doesn't return anything, but let's count to 99. And you can see if this first number is always going to be 1, but we can control the starting position. So it starts from 1 all the way up to 99. If we wanted to start from 63, let's say, then we just set the initial count to be 63, and then it starts from 63 all the way to 99. And yeah, you can see that this has implemented a recursive counting function. So that was the basics of recursion. Just remember to split it into base cases and recursive cases. The advantages of using recursion is that it's a lot simpler. Like, you can definitely make algorithms a lot simpler through recursion, but don't get caught up in using it all the time because it's not as efficient as using regular iteration. So yeah, thanks for watching, and that was recursion in JavaScript. See you guys in a future tutorial. Bye.